Vector field B equal to xi plus yj minus 2zk is defined over a conical region having height 2, base radius r equal to 3, axis along z as shown in the figure. The base of the cone lies in the xy plane and is centered at origin. If n denotes the unit outward normal to the curved surface S of the cone, what is the value of this integral b dot n ds? So the important thing to be noted over here is कि क्वेश्चन में हमें पूछा गया है दिस इंटीग्रेशन ओवर अ कर्व्ड सरफेस, राइट, कर्व्ड सरफेस S of the cone which is marked over here with the gray region. So why is this important is because S is only the curved surface. S is only the curved surface of cone. So अगर वो सिर्फ कर्व्ड सरफेस है, does it enclose a volume? Right? It does not enclose a volume V. It does not enclose a volume V. Why is this important is because many times what happens is कि हम लोग surface integration देखते हैं and then we are tempted to apply Gauss Divergence Theorem. तो Gauss Divergence Theorem कब अप्लाई कर सकते हैं? अगर हमारे पास कोई ऐसा सरफेस हो जो एक वॉल्यूम एनक्लोज करता हो और उस सरफेस पे अगर हम लोग ऐसा कोई इंटीग्रल निकालते हैं तब हम लोग गॉस डाइवर्जेंस थ्योरम अप्लाई कर सकते हैं. तो यहाँ पे S इज ओनली द कर्व्ड सरफेस, इट इज नॉट एनक्लोजिंग अ वॉल्यूम, सो वी आर नॉट इन अ सिचुएशन टू अप्लाई द गॉस डाइवर्जेंस थ्योरम डायरेक्टली. ऑलराइट, तो अभी कैसे कर सकते हैं इस क्वेश्चन को फिर? तो अगर हमारे लिए कोई इंटीग्रेशन ऐसा डिफाइन हो जाए विच इंक्लूड्स द एंटायर सरफेस ऑफ कोन, एंटायर सरफेस ऑफ कोन, ऑलराइट, और उसमें अगर हमको चाहिए बी डॉट एन डी एस, तो उस केस में हम लोग बोल सकते हैं कि दिस इज वॉल्यूम एनक्लोज्ड बाय द कोन डाइवर्जेंस बी विथ रिस्पेक्ट टू वी. ठीक है, तो वी कैन हैव दिस इंटीग्रेशन ओवर द वॉल्यूम ऑफ डाइवर्जेंस बी डी वी बाय गॉस डाइवर्जेंस थियरम, बाय गॉस डाइवर्जेंस थियरम. So now we need to create a situation where we are able to express this as a part of this. So clearly अगर हमको एंटायर सरफेस ऑफ कोन करना है तो एक उसका कर्व सरफेस रहेगा और दूसरा जो हो जाएगा दैट इज द सरफेस ऑफ द बेस. तो अगर हम लोग बेस को यहाँ पे मार्क कर ले, दिस इज द सरफेस दैट आई एम टॉकिंग अबाउट and since that is S, let's call this as S dash. So the closed surface that we want is nothing but the curved surface S and the base S dash. So we can write down therefore integration over the curved surface of B dot n ds plus integration over the base of B dot n ds. This is nothing but integration over the entire surface of cone, entire surface of cone of B dot n ds, and then by Gauss divergence theorem we can write this is divergence B dV over the volume enclosed by the cone. Right? So the required integral is this. So now I can say integration over S of B dot n ds is nothing but integration of divergence B over V minus integration over the base of B dot n ds. I hope everybody has followed this equation. So यहाँ पे हम लोग डायरेक्टली गॉस डाइवर्जेंस थ्योरम अप्लाई नहीं कर सकते, बट वी क्रिएटेड अ सिचुएशन और डिफाइंड एन इंटीग्रल सच दैट we are able to apply the Gauss divergence theorem. Right? So what is the vector field B that we are given? It is xi plus yj minus 2zk. So it is xi plus yj minus 2zk. So what will be divergence of B given by? So divergence of B is dou by dou x of the x component of the field, that is 1, plus dou by dou y of the y component, that is also 1, plus dou by dou z of the z component, which will be minus 2. So this turns out to be 0, and since divergence is 0, we will have this integral will be equal to 0. Alright, तो ये integration तो 0 मिलने वाला है हमको. So बचा अभी this integration that is over the flat surface of the cone. Alright, so now we'll look at integration on the base of B dot n ds. Alright, so let me just take the diagram over here. Okay, so this is the diagram. So this is the surface S dash that we have taken. This is the surface S dash. Alright, so what is B? B is xi plus yj minus 2zk dotted with n cap ds. Alright, so अभी इस सरफेस के लिए एस डैश के लिए एन कैप क्या है? व्हाट इज एन कैप फॉर दिस सरफेस? इट विल बी द आउटवर्ड यूनिट नॉर्मल. तो since the base is in the xy plane, that is mentioned in the question also, so the base of the cone lies in the xy plane. All right, so अगर base xy plane पे है, if this area is on the xy plane, its normal will be along the z axis. Its normal will be along the z axis. तो दो ऑप्शंस बन जाते हैं यूनिट नॉर्मल के, या तो प्लस के कैप या तो माइनस के कैप. ऑलराइट, बट सिंस वी वांट द आउटवर्ड नॉर्मल, the outward normal is going to be minus k cap, which is this, right? So n cap has to be minus k cap for our question, because plus k cap will be into the cone. Plus k cap into the cone rahega. We want the outward normal. So n cap is minus k cap, and that is what we'll have over here for n. So अगर ये डॉट करेंगे हम लोग तो माइनस माइनस will become plus. So this is simply 2z integration over s dash ds. All right. So integral 2z ds on surface s dash. ओके, सो अभी सरफेस एस डैश पे अगर हम लोग देखेंगे तो z की वैल्यू क्या होने वाली है? व्हाट इज z ऑन द सरफेस एस डैश? सो वंस अगेन एस डैश इज नथिंग बट इट इज लाइंग ऑन द एक्स वाई प्लेन, एंड ऑन द एक्स वाई प्लेन z विल बी इक्वल टू 0. तो z की वैल्यू 0 रहने वाली है पूरे सरफेस पे z की वैल्यू 0 रहने वाली है. सो इट्स लाइक वी आर इवेल्युएटिंग इंटीग्रेशन ऑफ 0. सो द आंसर हैज टू बी 0 सिंस z इक्वल टू 0 ऑन सरफेस एस डैश. सिंस z इज 0 ऑन द सरफेस एस डैश, तो ये इंटीग्रल भी 0 आ रहा है. सो जो सेकेंड पार्ट मिल रहा है हमको, दिस इज ऑल्सो 0, एंड सो दिस इंटीग्रेशन हैज़ टू बी इक्वल टू 0. तो जो रिक्वायर्ड इंटीग्रल है उसका आंसर 0 है. बट इंपॉर्टेंट थिंग टू बी नोटेड ओवर हियर इज दैट द क्वेश्चन वॉज आस्किंग अस टू फाइंड आउट द इंटीग्रेशन ऑन द कर्व सरफेस एंड नॉट द एंटायर सरफेस. राइट, सो सिर्फ कर्व सरफेस ऑफ कोन है तो इट डज नॉट इनक्लोज अ वॉल्यूम. वी कैनॉट अप्लाई गॉस डाइवर्जेंस थ्योरम डायरेक्टली. ठीक है, दैट इज द इंपॉर्टेंट थिंग टू बी नोटेड. So once we identified that, we created a situation where we can apply the Gauss Divergence Theorem. So this is how the theorem gets applied. All right. So we needed a closed integral on the entire surface of a cone. So we split or combined, or entire surface can be written as the curved surface plus the flat surface. All right. So that is how we ended up finding the expression. Integration on the curved surface will be divergence b over the volume minus integration over the flat surface. All right, and eventually on calculations we got divergence also 0 and integration on the flat surface to be 0. So the required answer is 0. All right, so I hope you have followed how to approach such questions where we cannot apply Gauss divergence theorem directly, but then we can create a situation to apply it. All right, तो अगर ये question clear है तो we have one more example. So now look at this question. Given a vector u bar equal to 1 by 3 minus y cube I plus x cube j plus z cube k, n cap is the unit normal vector to the surface of the hemisphere. So the equation of hemisphere is given. Value of the integral del cross u dot n ds evaluated on the curved surface of the hemisphere. So once again we have to look at only the curved surface of the hemisphere. All right. So let's get a diagram for this. It is a hemisphere. So it should be something like this. राइट, ऐसा कुछ एक हेमिस्फीयर रहेगा हमारे पास. इट इज़ गिवन दैट z ग्रेटर देन 0. सो क्लियरली द सर्कल और जो उसका बेस है दैट इज ऑन द एक्स वाई प्लेन. सो वी शुड हैव द एक्सिस लुकिंग समथिंग लाइक दिस. राइट, सो लेट्स से दिस इज x y and then this is z. So z greater than 0, that is above the xy plane, is where the hemisphere is lying. Right, so this is the hemisphere and then this is the curved surface S, that over which we have to evaluate this integral. Right, so once again since it is not enclosing a volume, right, volume enclose कब होगा? जब हम लोग कर्व सरफेस और नीचे का जो बेस है वो भी कंसिडर करेंगे साथ में तब. तो यहाँ पे तो सिर्फ कर्व सरफेस है, तो सरफेस S इज नॉट enclosing a volume. राइट, सरफेस S is not enclosing a volume. Surface S does not enclose volume V. Right, so Gauss divergence theorem डायरेक्टली हम लोग अप्लाई नहीं कर सकते. आई होप यू आर एवरीबडी इज फॉलोइंग दिस. ठीक है, दिस इज वेरी इंपॉर्टेंट बिकॉज ब्लाइंडली Gauss divergence theorem नहीं लगाना है हमको हर एक क्वेश्चन में. ऑलराइट, सो यू कैन अप्लाई इट ओनली व्हेन द सरफेस ऑन विच यू आर कैरिंग आउट द इंटीग्रेशन encloses a volume V. ठीक है, इट हैज टू बी अ क्लोज सरफेस. तो यहाँ पे S डज नॉट enclose वॉल्यूम V. तो अभी क्या करेंगे हम लोग? विल कॉल अगेन द बेस to be S dash. We'll call the base to be S dash. And then we know S and S dash together enclose a volume V. S and S dash together enclose a volume V. So I have integration over the entire surface of hemisphere of some force field F dot n ds. Right, we'll come to this later. Some force field F dot n ds. This is equal to integration over volume of divergence F. Right, so this is the Gauss divergence theorem. तो अगर हम कहीं से एंटायर सरफेस लेके आते हैं तो हम लोग गॉस डाइवर्जेंस थ्योरम अप्लाई कर सकते हैं. सो दिस इंटीग्रेशन कैन बी रिटन एज सम ऑफ इंटीग्रेशंस ओवर एस एंड एस डैश. ऑलराइट, सो वंस अगेन वी विल हैव integration over s of f dot n ds plus integration over s dash of f dot n ds will be equal to closed integration over the entire surface of hemisphere. So entire surface of hemisphere of f dot n ds, and this by Gauss divergence theorem will be integration over v of divergence f dv. Right, divergence f dv. So once again this is the required integral, so we'll have integration over s of f dot n ds equal to integral over v of divergence f minus integration over s dash of f dot n ds. Right, so this is the expression that we can work on. So फिर से I'll repeat. The question was asking us to evaluate a surface integral on the curved surface, and curved surface does not enclose a volume V. Right, so we are not in a situation to apply Gauss divergence theorem. So we created the situation by adding a surface integration which includes the base of the hemisphere. So curved surface plus base of the hemisphere will give the entire surface of the hemisphere. Now this encloses a volume V, so Gauss divergence theorem can be applied, and then we get the expression for the required integral. Right, now here what we are having is it is integration of del cross u. Right, so we have to find the surface integration of a field which is curl of some other vector field. Alright, so u bar is given. We first need to find out what is del cross u. Alright, so let's first note down u. U is 1 by 3 minus y cube I plus x cube j plus z cube k. Right, so minus y cube I plus x cube j plus z cube k. Alright, so del cross u first. Del cross u will be equal to, it will be I j k dou by dou x dou by dou y by dou z, and then minus y cube x cube and z cube. We can take 1 by 3 outside. So this will be 1 by 3. For I cap we are going to have dou by dou y of z cube which is 0, and dou by dou z of x cube which is also 0. So there is no I cap term. For j cap we will have dou by dou x of z cube 0, and dou by dou z of y cube minus y cube, that is also 0. So there will be no j cap term also. And for k cap we will have dou by dou x of x cube which will be 3x square, and minus dou by dou of minus y cube, so that is minus 3y square. This is with k cap. So 3 gets cancelled and we'll have x square plus y square k cap. Alright, so x square plus y square k cap is the curl of this field. Alright, now coming to the first integration that we have over here, which is over the volume of divergence f. Now f itself, f as it is defined in the question, is curl of u. Right, so ये integration में हमको चाहिए divergence of curl, and that is a property, divergence of curl of any vector field is 0. So this integration will be straightforward 0. If you want, you can check the divergence of this, you will get it to be 0. Right, so divergence of curl is 0, that's a property. So this integration is straight away 0. So now our only task is to find out what is this integral. Right, so now we need to find out integration over s dash of the field is x square plus y square k cap dot n cap ds. So to illustrate n cap again, let's take this diagram, right? So this is the surface which is again on the xy plane and the hemisphere is above it. तो फिर से हमको चाहिए आउटवर्ड नॉर्मल. तो सिंस इट इज ऑन द एक्स वाई प्लेन एंड इट इज अ फ्लैट फेस, द नॉर्मल इज आइदर गोइंग टू बी प्लस के कैप और माइनस के कैप. तो अगर हमको आउटवर्ड नॉर्मल चाहिए, इट हैज़ टू बी दिस वन विच इज माइनस के कैप, विच विल बी माइनस के कैप. सो द यूनिट आउटवर्ड नॉर्मल फॉर अस इज माइनस के कैप. So let's call this I. So therefore I will be equal to integration over s dash. So this is dot is going to be minus 1. So minus of x square plus y square ds, right? So since we are on the xy plane, we can again take that circle. So it is a circle on xy plane. It is a circle on xy plane. So we have it something like this, x y, and the circle will be x square plus this circle is going to be x square plus y square equal to the radius of the hemisphere, that is 1. So it is x square plus y square equal to 1. So let's suppose we take the strip to be vertical. If we take the strip to be vertical, then the limits for x will be, this is x equal to minus 1 to x equal to 1, and for y we will have y equal to minus under root 1 minus x square to y equal to under root 1 minus x square. So this will be minus x equal to minus 1 to x equal to 1, integration y equal to minus under root 1 minus x square to y equal to under root 1 minus x square of x square plus y square. First we will have integration with respect to y, and then this will be with respect to x, right? We have taken the strip to be vertical. So this is what we are going to end up with. So first with respect to y, so this will be x square y plus y cube by 3. So therefore I equal to minus integration minus 1 to 1 x square y plus y cube by 3, and limits being minus under root 1 minus x square to under root 1 minus x square, and then this integration with respect to x. So this will be minus 1 to 1. Clearly on substituting the limits, so y, this will become x square into twice of under root 1 minus x square. Alright, and this will be plus, this will also become twice, so 2 by 3 y cube. So it will be under root 1 minus x square cube, which can be written as 1 minus x square raised to 3 by 2. Alright, and this integration with respect to x. I hope you have followed this step. So okay, तो अभी हम लोग देख सकते हैं कि ये इंटीग्रेशन हम लोग डायरेक्टली कैरी आउट नहीं कर सकते. सो विल हैव टू गो फॉर सम सब्सटीट्यूशन. सिंस वी आर हैविंग अंडर रूट 1 माइनस एक्स स्क्वायर, the substitution that we can go for is x equal to sine theta. Alright, so x equal to sine theta, this will give us dx is cos theta d theta, and also 1 minus x square is under root 1 minus x square will be 1 minus sine square theta square root, that is cos theta. Right, so limits x equal to minus 1 pe theta will be minus pi by 2, and x equal to 1 pe theta will be pi by 2. Alright, so with this integration can be rewritten now. So we have therefore I equal to minus pi by 2 to pi by 2 of 2x square, so that is 2 sine square theta, into under root 1 minus x square, that is cos theta, plus 2 by 3. So it's 1 minus x square raised to 3 by 2, that is square root ka cube. So under root 1 minus x square is cos theta, and cos theta ka cube, that will be cos cube theta. And then finally dx is cos theta d theta. So cos theta d theta. So this integration is minus pi by 2 to pi by 2 of 2 sine square theta cos square theta plus 2 by 3 cos power 4 theta. Okay, so further again we'll have to get into trigonometric double angle relations and all to simplify this. So we have sine square theta, cos square theta, right? So this can be written as sine square 2 theta by 4. See if you're following this. And cos raised to 4 theta is can be written as 1 plus cos 2 theta by 2 squared. So it's like cos square theta ka square. Cos square theta square. So cos square theta can be written as 1 plus cos 2 theta by 2 and then the whole squared. So we'll try to do it simultaneously and just pay attention. I'll do it slowly so you understand it properly. So therefore I will be equal to minus integration minus pi by 2 to pi by 2. We are going to have sine square theta, sine square 2 theta by 2 plus 2 by 3 cos स्क्वायर थीटा को हम लोग cos पावर 4 को हम लोग लिखेंगे 1 प्लस cos 2 थीटा बाई 2 का स्क्वायर. So 1 plus cos 2 theta by 2 squared, and this with respect to theta. So this is minus integration over minus pi by 2 to pi by 2. Sin square theta को हम लोग लिख सकते हैं 1 minus cos 4 theta by 2, and then we already have a 1 by 2, right? So 1 by 2 तो इसका था वही, और sin square 2 theta is 1 minus cos 4 theta by 2 plus 2 by 3 into this will be 1 plus 2 cos 2 theta plus cos square 2 theta by 4, right? And this is the entire integral with respect to theta. So we have minus pi by 2 to pi by 2. This will be 1 by 4 minus cos 4 theta by 4 plus this is 2 gets cancelled over here. So we have 1 by 6 plus 2 will get cancelled. So cos 2 theta by 3 plus 1 by 6 cos square 2 theta. So cos square 2 theta can be simply written as 1 plus cos 4 theta by 2. Right? It can be written as 1 plus cos 4 theta by 2. Okay. So यहाँ से okay. So let's just take it properly forward. So this is equal to minus integral minus pi by 2 to pi by 2, 1 by 4 plus 1 by 6. So that is going to be 10 by 24, 5 by 12 minus cos 4 theta by 4 plus cos 2 theta by 3 plus 1 by 12 plus cos 4 theta by 12, right? So with respect to theta. So what we are going to have is, therefore I equal to minus integral minus pi by 2 to pi by 2. We have 5 by 12 plus 1 by 12, that will be 6 by 12, which is half, minus cos 4 theta, there are two terms, 1 by 4, that is minus 1 by 4 plus 1 by 12. So we will be having minus 12 plus 4, it's minus 8 by 40, 1 by 6. So that will be minus cos 4 theta by 6. And yeah, this is the last term, plus cos 2 theta by 3. Cos 2 theta by 3 with respect to theta. Okay, so this is just simple step by step moving ahead with the integration. This was the integral that we are looking at, right? ये circle पे हम लोग integration कर रहे हैं. So it turned out to be a lengthy integral. So I'll also share how to do such an integration in a short method. But first is like अगर हम लोग को directly करना रहेगा तो इस तरह से हम लोग कर सकते हैं. And we ended up with substitutions and in sin theta and cos theta. And then we just went on simplifying terms till we are having a integrable terms in front of us. All right. And then eventually we end up with this. So let's just verify. This is 5 by 12 plus 1 by 12, that is 6 by 12. So it is half. So this is minus 1 by 4 plus 1 by 12. So it's like 1 by 12 minus 1 by 4. So we get minus 8 by 48, that is minus 1 by 6. So that is minus cos 4 theta by 6 and then plus cos 2 theta by 3. So this is what we have in all. And now we can integrate this. So this will be minus of theta by 2 minus cos integration will be sine 4 theta by 4. So this will be 24 plus cos 2 theta will be sine 2 theta by 2 into 3. 2 into 3, that is 6. And the limits minus pi by 2 to pi by 2. So this will be pi by 2 plus pi by 2, pi हो जाएगा इस पे. So rather minus of pi by 2 आएगा यहाँ पे, minus sine of 4 theta. So the moment we make it 4 theta, it will be 2 pi, that is 0, and minus 2 pi will also be 0. So this term will become 0, and plus again we have sine 2 theta. So at upper limit it will be sine pi, and lower limit it will be sine of minus pi, which again will be 0. So this integration turns out to be minus pi by 2, right? So what was this integration? This integration was integration on the surface S dash, which was the flat face of the hemisphere, and it is minus pi by 2. So जो ये वाला इंटीग्रल है इसका आंसर हमको मिल रहा है minus pi by 2, right? This integral is minus pi by 2. So the required integral is 0 minus minus pi by 2. So the answer will be pi by 2, right? तो यहाँ पे देखो ऑप्शन में वो लोग ने minus pi by 2 भी दिया हुआ है. So don't be in a hurry to mark the answer as minus pi by 2. The answer will be option C, pi by 2, right? So this integration when evaluated on the curved surface of the hemisphere will be pi by 2, as we have found over here. So important thing again was like we cannot apply Gauss Divergence Theorem directly because S was not enclosing a volume V. So we created a situation and we added like the curved surface and the flat surface together will give the entire surface of hemisphere which encloses volume V. And so by Gauss Divergence Theorem we will be able to write this. And then we got the expression for the required surface integral as divergence f integrated over volume minus this integral. All right. So divergence of f, now f as per the question was curl of a vector field, and यहाँ पे हमको चाहिए था divergence of curl. So by property that was 0, so this integration is straight away 0. And then for this integration we ended up with a field which was x square plus y square k cap. Normal vector for this face which is outward pointing is minus k cap. So we ended up with this integration on the surface on xy plane, and this surface is nothing but a circle, x square plus y square equal to 1. It is the base of the hemisphere. So strip लिया vertically. So we get the limits for y and x, and then we proceeded with the calculation. तो y का substitution तो simple था, but the moment we ended up with the integration over with respect to x and entire thing was in x, we realized we cannot do it directly. So we went for substitution, made the substitution x equal to sine theta, and then all the other limits and all was calculated. And then the terms were not directly integrable, so we just applied double angle formulae, simplified the expression to end up with this, and then we eventually evaluated the integral to be minus pi by 2. So this surface integral, इसका value हमें मिल जाता है minus pi by 2, and so the answer for our question will be pi by 2, which is this integration. All right. So I hope you have followed that in such questions where you cannot apply Gauss Divergence Theorem directly, you can create a situation where you can apply the theorem. All right. Now over here, we had an integration which was integral x square y square dx dy. All right, which was on a circle. So let me just give you a short method of doing this, which is by switching to polar coordinates. It will be much faster. So the integral that we want is I equal to minus integration of x square plus y square ds, where s is the circle, x square plus y square equal to 1. Right. तो ऐसे टाइप के इंटीग्रेशंस के लिए हम लोग पोलर कोऑर्डिनेट्स यूज कर सकते हैं. सो द पोलर कोऑर्डिनेट्स आर x इक्वल टू r cos थीटा and y equal to r sin theta. So this is how we go from Cartesian to polar. So x equal to r cos theta, y equal to r sin theta. So whenever we have a double integral, so this is basically going to be a double integral. So this ds is nothing but dx dy. So जब हमारे पास कोई ऐसा इंटीग्रल है f of x y dx dy, this can be written as double integral of f of, now x in polar coordinates is r cos theta, comma y will be r sin theta, and then into, now what happens to this dx dy is it is replaced by magnitude j into dr d theta. So r and theta are the new variables. So j dr d theta, that is how we replace the given integral. Right. सो जहाँ पे x और y है वहाँ पे तो हम लोग r cos थीटा r sin थीटा सब्स्टिट्यूट कर देंगे इन दिस इंटीग्रेशन, एंड देन वेर एवर वी हैव लाइक जो dx dy है दैट पार्ट गेट्स रिप्लेस बाय j dr d theta. Now what is this j? This j is nothing but Jacobian, which is like we can say it is partial of x and y with respect to r and theta. It combines the partial derivatives of x and y with respect to r and theta. So it is given by this determinant dou x by dou r, dou y by dou r, dou x by dou theta, dou y by dou theta. So यहाँ पे क्या होने वाला है वो, what will be the Jacobian be equal to? So I'll just write it slightly down over here. So this will be equal to, this is a separate part. So the Jacobian will be dou x by dou r. So what is dou x by dou r? It is simply cos theta. Similarly, dou y by dou r is sin theta. Dou x by dou theta will be minus r sin theta. And dou y by dou theta will be r cos theta. Will be r cos theta. So this will be r cos square theta and minus r sin square theta. So we have a r cos square theta plus sin square theta, which will be simply r. So the j for switching from Cartesian to polar coordinates turns out to be r. तो जो हमारा इंटीग्रल है f of x by dx dy will be replaced as f of r cos theta r sin theta into r dr d theta. Alright. So what this means is the integral I, which is minus double integral of x square plus y square dx dy over the circle x square plus y square equal to 1, can now be written as minus integral over the circle x square plus y square equal to 1. Now x is r cos theta, so this will be r cos theta square, plus y is r sin theta, so this will be r sin theta square. So this is what happens to that f of xy that we had over here, f of xy, and then dx dy will be written as r dr d theta. Right? So dx dy is replaced with j dr d theta, and j for this transformation turns out to be r. All right. So this is the integral in front of us. So this is nothing but integration on x square plus y square equal to 1 of, this is going to become r square cos square theta plus r square sin square theta, which is going to be r square, and then we have another r and then dr d theta, and not to forget there is a minus sign with the integral, right? So this is minus integral of r cube dr d theta. Now since the region of integration is the entire circle, r will go from 0 to the radius of the circle, which is 1 in this case, and theta will go from 0 to 2 pi. तो थीटा 0 से 2 पाई जाएगा, r 0 से रेडियस ऑफ द सर्कल दैट इज 1 तक जाएगा. ऑल राइट, सो वी कैन राइट दिस एज 0 to 2 pi, minus sign is there. Then we have integral 0 to 1 r cube dr d theta. So this is 0 to 2 pi r raised to 4 by 4 limits 0 to 1 with respect to theta. So therefore I equal to minus integration 0 to 2 pi. So when we will put the limits, this will be simply 1 by 4 with respect to theta. So we get minus of theta by 4, limits being 0 to 2 pi. So this will be getting is 2 pi by 4 or simply minus pi by 2, right? So we get I equal to minus pi by 2, and this I is nothing but this integral, which was actually the surface integration of this field on the base of the hemisphere, right? This is what this I is, right? So जब हम लोग ने उसको पूरा कार्टेशियन कोऑर्डिनेट्स मतलब एक्स वाई में सॉल्व किया by doing this method of substitution and all, we had ended up with minus pi by 2, and now with this method of switching to polar coordinates we will again end up with the same answer obviously, but then this method becomes faster. तो आपके पास दो चॉइसेस है, या तो आप जो स्टैंडर्ड तरीका है उसमें मेथड ऑफ सब्स्टिट्यूशन वगैरह लगा के यू प्रोसीड विद द क्वेश्चन, जस्ट डू इट केयरफुली स्टेप बाय स्टेप, or you can also think about switching to polar coordinates. So this integration on the base of the hemisphere turns out to be minus pi by 2, and then this was already 0. So the answer for our question becomes pi by 2, which is option C. So I hope you have understood how to approach such type of questions where we are evaluating a surface integral only on the curved surface of some object and it is not enclosing a volume V. तो ऐसे क्वेश्चन में कैसे हम सिचुएशन क्रिएट कर सकते हैं जहां हम गॉस डाइवर्जेंस थ्योरम अप्लाई करके क्वेश्चन इजीली सॉल्व कर सके.